way this can happen is if P, assume that P is even or Q is even, and the other one, P or Q, is prime and odd. We can test out the cases. So if P is equal to 2, that's the only even prime. That's equal to 6 plus 5Q is equal to 31. Then you get 5Q is equal to 25, or Q is 5. Now we can just plug it in. Now we get P, remember we actually set it to be equal to 2. 2 divided by 3 times 5 plus, 5 plus 1. Alright? Now this is equal to 1 over 8. Now from here, notice that there's going to be 2 answers for each one, except for this one. This one doesn't work. Obviously, since it's 5, and we already found one answer as 1 over 8, right over here. So there must be another case, which what is it? That's if Q is 2. So if we plug in Q, that is equal to 2. I'll just erase all this work. Q is equal to 2. Then P has to be equal to, well, 3P plus 10 is equal to 31. From here, you can solve, and you'll see that P is equal to 7. Now we'll plug it in again. We get 7 divided by 3 times 2 plus 1, or 7 divided by 7, or equal to 1. So we have 2 answers now, 1/8 and 1. And there's only these 2 are the only answers, alright? So the answer to this question is just A. Since that's all the answers we can get by letting P equal to 2 and Q equal to 2. Because remember, an odd plus an even must be equal to odd. And an odd plus odd cannot be equal to an odd. Alright? Let's move on. Example 15. If M is the greatest prime factor of 57 and N is the greatest prime factor of 120, what is the value of M plus N? Well, we can factor for each one. Alright? If we think about it, what is the factors of 57? Well, 57, if you do the division, you notice that this is divisible by 3 and 19. And N is just 57 is 3 times 19, and 120 is just 3 times 4 times 10. Or we can easily simplify to 3 times t cubed times 5. Or 3 times 8 times 5. Alright? So what do we do from here? Well, what is the largest prime factor of each of them? Well, 19 is the largest prime factor for 57. And 5 is the largest prime factor in this case for N. So N is equal to 5 and M is equal to 19, right? Because this is the largest prime factor, and that so is this one. And we want to sum them up. Well, summing them up gives you, gives you 19 plus 5, or 24. So the answer to this question is just C. Alright? Now let's move on to problem 1. The prime number P is a factor of 70 and is also a factor of 105. How many possible values there for P? I'll ask you guys for trying this question and tell me through chat. Private message, please. Me the answer. Let's get started with this question. So, how do we approach this? Well, as we talked about before, we might as well just use the prime factorization. Now, let's go factoring it. Well, notice that 70 can be written as 2 times 5 times 7. Right? Since we know that 70 is equal to 2 times 35, and 35 can be written as 5 times 7, this just becomes 2 times 5 times 7. Now, we also factorize 105. Now, how do we do this? Well, we can see that 105 is divisible by 3 and 5. Because the sum of these digits is just 6, which is divisible by 3. So, we can divide this number by 15, and you'll end up with 7 also. So, 70 is 2 times 5 times 7, and 105 is 3 times 5 times 7. These two numbers are both divisible by 5 and 7, which means the answer to this question is 2. Since these are prime numbers, and they're both factors of 70 and 105. Alright? Now let's move on to problem 2. Which of the following is not an element of both the set of positive odd integers and the set of prime numbers? Well, how do we approach this? Now, we can first list out all the positive odd integers and set of prime numbers. Well, 1, 3, 5, 7, that's the odd numbers. We got the positive ones. And so on. Now, what about the prime numbers? Well, the prime numbers are 2, 3, 5, 7, and so on. So we can see that 1 and 2 are not in, but we only have these answer choices. So we only care about these. And how do we know this? How do we find the set of the integers that are not in the prime number section that are odd? Well, one way to do this is to notice that this number has to be composite or be divisible by more than two numbers. The two numbers is prime. If you divisible by two numbers, it's prime. So example 7 does not work. This is only divisible by 1 and 7. Now, we talked about this before. That 57, right over here, 57 is divisible by 3 and 19. So from here, we know that 57 is composite. That's our answer. Alright? Now let's move on to problem 3. How many integers greater than 20 and less than 30 are each the product of exactly two prime numbers? I'll ask you guys have a try on this question and tell us in the group chat. All right, let's get started with this question. So how many integers greater than 20 and less than 30 are each the product of exactly two prime numbers? Well, let's start out by listing all the numbers that follow this description, all right? 21, 22, 23, 24, 25, 26, 27, 28, 29. So we got these, all right? Notice that 29 does not work. Any prime number in this case does not work, since we want two prime numbers that you multiply together and you get a composite number. And exactly only two prime numbers. Similarly, we can rule out 24. 28 does not work. 27 also does not work. So we're left with these cases. And they turn out that all of them work. 21 is 3 times 7. 22 is 2 times 11. 26 is 2 times 13. And 25 is 5 times 5. Alright, all four of these numbers are divisible by, all four of these numbers can be multiplied by exactly two primes and get the number itself. So the answer to this question is just 4. Alright, now let's move on to problem 4. What is the sum of the first 10 prime numbers? Let's go to try this question and type it through chat. Let's get started with this question. So basically, how are you supposed to approach this? Well, one way to do this is to just add them all up and find them out. So that's the most way, unless you just memorize these prime numbers and you know the sum already, or if you've done this question before. But this is the most straightforward way I think everybody's gonna do. So you just list out all the prime numbers, the first 10 actually, and you sum them all up. Now, I'm not summing them up, but the answer to this question is just 8. If you add them all up. 2, 3, 5, 7, 11, 13, 17, and you add in a 19 and a 23 and a 29. These are the first 10 part numbers, and if you sum them up, you indeed get 129. Alright. Also want to problem 5. The sum of three consecutive primes is 159. What is the largest of the three primes? Let's go to try this question and tell me this through chat. Let's get started with this question. So how do we approach this? Well, it's given that these are three consecutive primes. All right. Instead of thinking we let the first prime to be p, second prime to be p plus whatever, we at first let the middle one be a prime number. Let's say p. Why? Because then we do not have to worry about the the difference. All right? Since it's a consecutive, we don't have to worry about the difference anymore. So we can say that's 3p. Since p minus a, say the a is the difference, plus p plus a plus p, that's just cancels it all out. The a's all cancel out, and we only have one variable term, which makes life so much easier. All right? Now we get 3p is just equal to 159. And then we get p is equal to 53 as our answer. But that's not the largest. So we can easily see from here, it's very, very simple, that we want the largest of these primes, which comes out to be 61, I think, if I'm right. Uh, Let me check. Yep, I think I'm pretty much right. If I did a simple mistake, let's see. Oh yeah, it's 59. Should be 59, right? Since the only primes between 50 and 60 are 53 and 59. So 59 is the next prime number, so that has to be the consecutive number. So the answer to this question is the largest is 59 or C, right? Make sure you don't make mistakes, all right? Like for example, assuming 61, that pops out to your head. Well, let's check. Let's see if it's 57. Well, is that prime? No, it isn't. So that's not the answer. So it has to be 59, since 59 is prime. Alright? Now let's move on to problem 6. How many pairs of distinct prime numbers have a sum of 22? Now, how do we get this? Well, that's going to be coming from two evens or two odds. But you want distinct prime numbers. So we know 2 is not in it. Now we only want on prime numbers now. Now it just comes down to be casework. We can easily list every single prime number that's less than or equal to 22. Let's list them out. Well, let's have the ones that we need to. Since we can do 3 plus 19, which is equal to 22, but that's the same as 19 plus 3 equal to 22. So let's start. 3, 5, 7, 11, 13, and then we'll stop. Alright, because 15 is just going to be 7, partner. So we're going to start. So 3 in this case goes well with 19. So that's one pair. 5 goes with 17. It's another pair. 7 goes with 15. But that doesn't work. So we can cross it out. 11 goes with 11. These are not distinct though. That's the important part. So we have to rule this one out. 13 in this case goes with 9. And that's not prime. So all we have left is 17 and 19 and 3 and 5. These are the only pairs we have. So that's 2 pairs. So the answer to this question is just B. Alright? Now let's move on to problem 7. The sum of 3 prime numbers is 38. Find the largest number of primes. Alright? I'll let you guys have to try this question and tell me this through chat. It's really similar to the last question we did. But it's not consecutive. Alright? All right, let's get started with this question. So how do we approach this? Well, notice that this does not say consecutive like the last one, all right? So we know we can choose any prime, a bunch of prime numbers we choose from. Now, less than 38, obviously. But then how do we go on this? Well, notice that if we sum up three odd prime numbers, all right? If we sum up three odd prime numbers, then that's not going to be even. So we must have one of these prime numbers to be 2. So that rules out one possibility, all right? 38 minus 2 is just 36. Now, what sum with prime numbers can we get such that if we add them all up, we get 36? Or sum of the two prime numbers? Well, since we want to find the largest of the primes, well, it's pretty obvious. We can go from 3 and then go to 5 and then so on. From here, notice that if we choose 5 and 31, this sums up to be 36. They're both prime, and this one's the largest of them. 31 is the largest. Alright? So the answer to the question is just D or 31. Since that's the largest. Alright? Notice that 3 does not work because 36 is divisible by 3. Which means that it's not going to be prime. Alright, let's start it with problem 8. The Goldbach conjecture, which has not been proven, states that every even integer greater than 2 is expressible as the sum of two prime numbers. In how many ways can the number 36 can be expressed as the sum of two prime numbers? Let's take a try on this question in timers through chat. All right, let's get started with this question. So basically, how do we do this? Well, this is going to be a lengthy problem. Why? Because we got all these cases we got to go through. Thankfully, we've already found one way 36 can be expressed in. 31 plus 5. All right? This is going to be a lot of piecework. All right? So just find out all the possible values. That's all I can tell you. That's the only way to solve this. All right? There's no smart way. So if we do that, we'll find that 531 works. 1323 works. 1719 works. And finally, 7 and 29 works. So the answer to this question is just A. Alright, now let's move on to example 16. Jerry chose a 4-digit number to be the personal identification number for his bank account. The first digit, leftmost digit, is prime. The greatest common factor of the middle two digits is 2, and the last digit is the divisor of 20. Which of the following numbers could be his personal identification number? I don't know why he's doing this. Whatever. So, the first digit is leftmost is prime, alright? So we can immediately rule out E. The greatest common factor of the middle two digits is 2. We can rule out B since 4 and 7 do not share a factor of 2. And the last digit is the divisor of 20. 7 is not a divisor of 20, 4 is, and 3 isn't. So we're left with C, so the answer to this question is just C. Alright? Chances are it's not his bank account number. Anyways, let's move on to example 17. For three positive prime numbers A, B, C, AB is equal to 55, BC is equal to 35. What is the value of ABC? Well, AB can be expressed as 55 and can be expressed as 35. Well, this is pretty obvious from here. Since B is in 55 and B is also in 35, well, B must be 5 then, since that's the only way B can be to divide 55, and B can also divide 35. That's only if B is 5, which comes obvious to 11 times 5 and 5 times 7. So A is 11, B is 5, and C is 7. Multiplying all of this together, you get 300. The multiplying this all together, 11 times 5 times 7, this just gives you 385 as your answer. Alright? Now let's move on to example 18. I'll let you guys have a try on this question and tell me your answer to chat. All right, let's get started with this question. So basically, how do we approach this? Well, we first have to list out every single prime number that follows it. Well, the prime numbers is, notice that 2 divides it, 5 divides it, 3 divides it, and 7 divides it. 3 times 7 is 21, and multiply that by 2 times 5, that's going to give you 210. So these are all the prime numbers. Now, how many of these prime factors are greater than 2? Well, that's pretty obvious. 5, 3, and 7. So the answer to this question is just 3 or C. Since 2 is not greater than 2. Alright? Now let's move on to example 19. What is the product of the prime numbers between 30 and 40? I'll ask you guys to try this question and tell me the answer through chat. Well, let's get started with this question. So how do we approach this? Well, first off, notice that there aren't really that much prime numbers between 30 and 40. Specifically, there is only 31 and 37. Right? That makes life so much easy. So it's just multiplying two integers. Alright? Multiplying them up, you get 31 times 37. Do your multiplication. This should give you an answer of 1,147. Alright? So the answer to this question is just C. Now let's move on to example 20. The difference between two prime numbers is 101. What is the value of the larger prime number? Let's get to try on this question and tell me answers to chat. And for a little hint, it's pretty straightforward. Alright, let's get started with this question. So, this is pretty straightforward, alright? It's just 103 minus 2 is equal to 101. Alright? That's why, because if you want an odd number as the difference, we want to have an even and an odd. So we subtract. So obviously, the first thing that comes up to mind, what if we have 2 and 103? Obviously, that works. Because 1 to 3 is indeed prime, so the answer to this question is just B. Alright, pretty straightforward. Now let's move on to example 21. Two prime numbers P and Q satisfy the following condition. P equals m plus n and Q is equal to mn, where both m and n are positive integers. Find the value of P to the Q plus Q to the P. Alright? Tell answers to the chat. All right, let's get started with this question. So, how do we approach this? Well, notice that P and Q are prime numbers, all right? And P and Q satisfies the following conditions. P equals N plus N, and Q is equal to N times N. Clearly, one of M and N are 1, all right? So, we get Q is equal to 1 times, say N is 1, okay? We get Q is equal to M, and P is equal to M plus 1, which is pretty obvious from here, since the only prime numbers P and Q that satisfy it is 2 and 3. So P is 3 and Q is 2. Adding these up gives you 2 cubed plus 3 squared, or 17, or D as our answer. Alright? That's it for today's class. I hope you guys have a wonderful weekend, and I'll see you next week. Bye.